So today in chemistry we'll do some exercises. But first, I'd like to show you what's the the exercise about. So right now we are on chapter 11 of our book, and we're talking about titulation. So it's a bit complicated. So let's begin. Well, the thing is that we have an Erlenmeyer, and excuse for my horrific drawing abilities, but I guess this can be called an Erlenmeyer. We have a stance over here, okay, uh, and is holding a little pipe, okay. We have a pipe over here, and we have an unknown solution over here, okay, and we want to know the concentration of this frick, the concentration of this solution, okay, and sorry for that. Let's say that the orange one is HSO4, okay? Let's say we have 10 milliliters of that, and I want to know the concentration. And we have the blue one, which is, we know that HSO4 is a, begins with H, so it's a acid. We have Na, and it ends with HOH. And so that's a base. And let's say we have, okay, so we don't know that yet. Uh, and I know the concentration, which is zero point 0.1 moles per liter. Okay. And so what we're gonna do is that we have our HSO4 over here, and we're gonna put phenolphthalein. Wait a minute. It's this thing over here. Yeah, phenolphthalein. And we're gonna put this here, and we know that the substance is an indicator. It indicates if it's a base or a an acid. If it's an acid, it's in color, has no color, and if it's a base, it gets rose. It gets pink, and so we put a couple drops, and everything is gonna be has it's going to be without color, transparent, and then we're going to drop the the NaOH. We're gonna drop it until we get everything pink, because we're going to be neutralizing the acid, which is HSO4, and we'll be neutralizing it until we have a complete neutralization, and it's going to be everything pink, okay? And we count how many milliliters we took, which in this case was 20 milliliters, okay? And so now we want to know the concentration. So first step, uh, we got first things first, we want to know how many moles we have on the blue NaOH liquid, one can say. So we have zero point 0.1 moles, and guess what? 1 liter. How many moles do we have in um, 20 milliliters? So we have 20 milliliters times 1 liter divided by 100,000 milliliters. So 1 liter is 1,000 milliliters. And so it's 20 divided by 1,000. So 2 over 100. Or just 2, 20 times 10 to the negative 3. Okay. So we have liters. And so we have 20 divided by 0.1, which gives us x being equal to 2, 2.0 times 10 to the negative 3. And this is not scientific notation because there's a few rules, like can't be greater than 10, and here we see 20. Okay, it's just a how it describing the multiplication. So we have the quantity of moles here. Now we want to know how many milliliters there was here. Okay, so we want to know the same thing up here, how many moles there was. So we know that NaOH plus HSO4 is gonna give us a salt and water, right? So we have Na with SO4 plus HOH, aka H2O. Now let's balance this out. We have NaSO4, and this doesn't exist. We need to put a 2 over here. This exists, so we have to multiply it over here by 2. So 2Na, 2Na, SO4, SO4, 2H's, H2. Yeah, it's balanced. So we need 2 moles of this per 1 of this. Okay, so we have 2 moles of NaOH to 1 of HSO4. And if we had 2.0 times 10 to the negative 3, we should have, in theory, 1.0 times 10 to the negative 3 to the negative 3. Okay. Okay, now we know that we have 1 mole, 1.0 times 10 to the negative 3. And we know that we had that quantity of mole in 1 milliliter. 10 milliliters actually. 10 milliliters. So we'll have X in, you want to know in liters, that's 10 times 10 to the negative 3. That's gonna yield the actual answer, which is surprisingly X is equal to 0.1 moles per liter. Now that we have understood it, we're going to do some exercise. So buckle up. On the titulation of 10 cubic centimeters of a solution of KOH, there were consumed 18 and a half cubic centimeters of a solution of H2SO4 that has a concentration of 0.25 moles per liter. Calculate the concentration in moles per liter of the KOH solution. Okay, so now our orange solution is KOH, which we have 10 cubic centimeters. Let's just put that on to milliliters. Okay. And by the way, 1 cubic centimeter is 1 milliliter. Therefore, we have 10 milliliters of KOH. Okay. That has a concentration of, that's what we want to know. And the blue one is H2SO4. We have 18.5 milliliters with a concentration of a quarter, 0.25 milliliters, no, moles per liter. Okay. Okay, let me just okay, so same thing, we just change letters. First things first, we want to know how many moles we have in 18 milliliters. So we know that in we have 0.25 moles in 1 liter. How many moles do we have in, how many moles, it's mole do we have in 1 liter, right? That's what, in 18.5 times 10 to the negative 3. Don't forget liter. Well, we have, let us do the calculation. That's 18.5 divided by, oh boy, that's 18.5 divided, oh boy, again, okay, 18.5 divided by 1000, that is 0.0185. And now we multiply that by 0.25, given as 0.004625. This is the same thing as putting a 0 in the front. No, that's the same thing. So that is 4 times 1, 2, 3. If I multiply by 100, 1000, okay, so that is here. So we have 0.004625 moles in that quantity. Does that make sense? Yes. We have 1 liter, and here we have 18 milliliters. We have 0.25, and here we have 0.004. Yeah, that makes sense. Okay, so that is how many moles we have. And now let us do the calculation. We have KOH plus H2SO4. That's gonna yield us water, H2O, and a salt, which is KSO4. And so we have 1K, 1 F5Os, the same thing. We need to add a 2 here because that doesn't exist. And so let's see, we have 2k over here, so we must have 2k also here. We have s 1s over here, 1s over here. We have 2sh down here, and we have 1 and 3. We have 4 h's. Boy. And with that, I need to multiply by 2 over here. Now everything's good to go. So we know that we need 2 KOH to 1 H2SO4. Which, by the way, where did I take that from? Okay, H2SO4. Yeah, okay, so it's 2 to 1. So now that is 2 to 1. So we have KOH that I don't know is 0.00462 okay, just multiply by 2, so get that and multiply by 2. Now actually add this one, multiply this by 2, and we get 0.00, so x is equal to 0.00952. Is that what I saw? No, it's 25. Okay, and now same thing. So we know that we have 0.00925 in 10 milliliters. So how many do we have in 1 liter? How many moles do we have in 1 liter? Remembering that is 10 times 10 to the negative 3. So that is 0.009 divided by 10 times 10 to the negative 3, giving us 0.925. So that's the answer, 0.925.